Thank you very much, Annabelle, for a wonderful introduction, and thank you very much for the League for making me introduce this lecture, also in honor of my friend, Ricky Franzen. And I like to make an introduction like what architects do, because as architects, we develop a dialogue of one's work to another work. It's like a history. You look at somebody's building, you're inspired by it, and then you make a creation, then history goes on. So I like to make a little story about me, starting with Frank Lloyd, Ricky Franzen, and Werner Sobek, in some way or the other, in that order. So first slide, please. Is that, okay? This is not a lecture about Frank Lloyd Wright, but this is a project, Darwin Martin House, which I won a competition for. And I'm showing this because it's a visitor center, and I had to really study the legacy of Frank Lloyd Wright. And I'm showing this because the way I met Ricky years ago, nearly 5 years ago, I showed him the competition scheme. And competition scheme is a very simple pavilion, and sitting next to it, it has a strategy of opposite of Frank Lloyd Wright by reverse hip roof, glass enclosure, masonry wall in the back. It's a larger than house, but also has this residential scale which reflects the neighborhood, which is designed by Olmsted. Can you hear me? Yes? Okay. So this is a design I showed him and explained my strategy, and Ricky says, this is his house, Towers House in Essex, Connecticut. He designed in 1963. So we both decided great minds think alike. And, but in a way, my interest was really more Mies van der Rohe and Corbusier, originating from the education of Cooper Union. And Ricky studied at the GSD, Walter Gropius, and classmate of Harry Philip Johnson, so the modernist genre. So we realized we are the origin of a common designs while we are generations apart. So there's a dialogue I started with Ricky about architecture. This is a plan, it's the house, and this is my plan. It's kind of squat and elongated, but similar concepts, three-sided glass, masonry in the back. And that's a dialogue also. As a result, I created with the Darwin Martin House as a lens, building being a lens to frame Frank Lloyd Wright's house. And this particular project is also idea of this cantilever outside. You see, this is really interesting. So to me, my dialogue with Ricky is not really all about what we talk about, but the mindset of architect, how we see the world, materiality, idea of spatiality. So it's especially an honor for me to be introducing this lecture in terms of this type of communication amongst colleagues, architects' collegiality. So I think that's another spirit of this particular lecture. In the back of it, I have made a masonry wall which imitates the pattern of Darwin Martin House. So it's like a palimpsest of, but it's in casting concrete. It's a very different material. To the back side of a house. So in a way, it's a house that I did not know about. And then in a sense, how do you say, historical coincidences, but I would have to say that subconsciously, I have, in evolutionary time, I have a DNA of your work, Ricky. There's nothing I can say about it. So, and this is a building, and this building also has another trait, which is the essence of this lecture series, which is environmental design. I have collaborated closely with Matthias Stuhler of Stuttgart. Stuttgart turns out to be a city where it has many engineers, structural engineers, environmental engineers. They have this ethos about efficiency, about use of materials, about intelligence, of understanding a building craft. So with this particular building, he did complete modeling, and it's a non-profit project. And what happens is that my client it would be nice, they said, to have a LEED label, but what they really did not want was spending a lot of money on electricity bills and energy bills. So they told me to make a light footprint for all the aspects of it. So geothermal, including the historical house, this entire site is geothermal, heating and cooling, radiant cooling and heating on the floor level, and ventilation works in convection instead of big duct running through. And also the roof is designed so that you are introducing daylight all the time. When the building operates, there's no need for electrical lighting at all, except in evening. And even evening, it's very subtle. There's no lighting in the ceiling surfaces or bottom lit up. And back wall you saw is also acting as a mass to protect it from prevailing wind coming from Great Lakes. So there's a lot of clever strategy. On top of it, Buffalo, this is located, has a lot of snow, and this particular shape of a roof is designed to take the snow in as a very effective insulator. So in a way, it's working with climatic issue and climate issue, but also embracing the negative aspect, but making it a positive. So I'm introducing these kind of ideas simply because you will see a lot in Werner's work today. And these are roofs and structures, and this is a night view, worked with Arab lighting, everything's lit up, diffused indirect lighting, that's working that way. Another building, in terms of environmental aspects I'm working on, which we just finished the punch list yesterday, and scientists are moving, is the Center of Excellence for Energy and Environmental Systems at Syracuse University. It's a federation of 15 individual organizations, including Rensselaer, Cornell University, psychology department, sociologists, Korea Air Conditioning, United Technologies. It's a federation of corporations and academia to study the impact of environment. The building is considered to be a living lab, so that interstitial space which you see in truss area, you put in different type of air conditioning or venting systems to really see, quantify the effects of efficiency of machinery of environmental control. And the building is also housing indoor environmental control, which is monitoring performance aspect in terms of how it affects human environment, so that we think lighting, natural lighting is very good, but no one really quantified how efficient it is in terms of productivity. So the scientists there, this building was really conceived by scientists there. Before the current president, I think we have a better outlook and support for the environment now. I hope we get a better policy. I think New York City current mayor has been very active in instituting policy and directing us the right way. But for the scientists at that time, when this building was conceived about 5 years ago, only way they can really prove economic viability is to prove that human productivity. And for them, there was a data in which if there's a 1% increase in thermal comfort, in general, it will pay for the energy bill for office buildings. And for example, there's a data that better lighting, both natural and artificial, will improve 7% of human productivity. So for them, the scientist was holy grail of how to go in terms of environmental strategy. But this is a kind of project I was working on. Also, it's important to point out this building is designed so it can stand on its footprint in terms of energy and water use. It only uses its rainwater harvested through the roof and also irrigates the landscape. And in terms of energy, there's many strategies are built in it, including solar panel, photovoltaic, south-facing facade, and wind turbine is there, geothermal. Also, biofuel lab is in this tail of a building, which, if it's in full operation, will provide 99% of electricity. So the building is designed essentially to harvest water on its own footprint and also to operate the energy it harvests and even give back. So that was a parameter for the brief of this. Now, getting back to the introduction part of it, I have to say tonight's lecture is about somebody, Professor Werner Sobek, who's able to connect many dots over very large issues. Population growth, you've been hearing, by 2030 there will be 8.4 billion people on Earth. By 2050 there will be 9.4 billion people on Earth, and half of them already dwell in urban dwelling. By prediction of America 2050, there will be 70% of population will be living in urban area. Now, everybody's talking about population growth in terms of why can't you control it? But one has to understand it takes into account decrease in mortality rate and increase in longevity. That means if they have to be seriously controlling population growth, I think they have to start killing us. So you have to understand that only way one can work with this incredible population growth number is managing it. So I think something about how to manage it in the management has to take place in urban context. That is a global, local, and also professional issue that we need to focus on. In terms of energy, we use 85 billion gallons of oil daily in the world. By year 2035, at this rate, we'll be using 90 billion barrels of oil daily. So where do they come from? Do we change the practice? Do we have to do something quite drastic about it? This is something we have to think about because buildings in urban area uses about 40% of total energy, and carbon emission is nearly up to 70% in cities like Boston or New York, so what to do with it? So it looks like a global problem, but it becomes local and professional issue very immediately. Water shortage. This is very serious. By year 2025, 2/3 of a population will be living in severe water shortage, and 1/3 of them in absolute water scarcity. That's 2025, not so far from that. The buildings waste energy, uses energy, but it can also harvest it, you can turn it around. Climate, as you know, a big issue, so I'm not going to go into temperature things that scientists are arguing about, but Arctic ice, between 1979 and 2007, there's a 43% receding of a level of Arctic ice. So what is happening with that rate, 2050, there will be no summer ice in Arctic North Pole. So what do we do with this particular climate? So to just set up these big challenges and parameters, one of the reasons that we have invited Professor Werner Sobek is he's somebody who can connect dots and then identify the real problem, in a sense. He knows how to ask right questions so that we can come up with the right answers. He is trained in engineering and architecture, and so that he knows how to design as well as how to solve it. He is from Stuttgart, Germany, where the chancellor is a scientist who understands thermodynamics, whose parliament is fueled by vegetable oil, and Green Party is very strong. So to a lot of extent, there's ethos in this particular country that I think promotes agendas and disciplines that Professor Werner Sobek also is promoting. And we were just laughing because he is a third speaker of a Franzen Lecture, and the first one was Renzo Piano from Italy. The second speaker was Shigeru Ban from Japan, and third speaker is Professor Werner Sobek from Germany. About 60 years ago, we were called Axis of Evil, but Werner says we should call us Axis of Eco. So I think that's solved that question there. And one of the interesting aspect and also profession and discipline of Professor Sobek is he's an engineer, means that he actually has both knowledge in terms of structural engineering as well as environmental technology, and also in terms of material sciences. And I have to say that is very rare, that architects here, you probably have to find like 5 different consultants to figure out those 3 areas. But the advantage is that his practices embraces all of them and then combines them, so he knows the interdependence between structures, environmental technology, and the material performance. He has give and take, and the conversations that goes on in terms of that. He has founded Werner Sobek Group in 1992. In 1994, he became a professor at University of Stuttgart, Germany, succeeding Frei Otto's position in lightweight structures. And he has also succeeded the position of concrete structures, which was also run by Professor Joerg Schlaich. 2 institutes came together. In year 2000, he founded the Institute for Lightweight Structures and Conceptual Design. And this was very important effort academically because this is one of the first institutes to unite the discipline of architecture and engineering so that both architecture students and engineering students can work together, and then they can be taught together. So there's a synthesis of 2 disciplines is what he is actually aspiring in terms of teaching and research he is going forward. In fact, Harvard GSD and his institute had collaborative relationship. We had Martin Bechtold, who is now a structural professor, has taken his students, architecture students, and collaborated with Werner's engineering students. 2007, I invited him to teach a design studio at Harvard GSD, and his program was to build a temporary pavilion in Samoritz on ice, on sheet of ice. So it has to be incredibly light, and therefore this idea of lightness is important in terms of both carbon footprint, energy use, also in terms of weight. So you can imagine how idea of lightness had to be such a synthetic idea and well considered and integrated in terms of design and technique, technology, and engineering. He had an exhibition, Show Me the Future, in Munich in 2004. In 2008, he's been the president of the German Sustainable Building Council. 2009, he was given honorary doctorate from University of Dresden, and since 2008, he has been a Mies professor at the Illinois Institute of Technology. He is a winner of numerous awards, including Benedictus Awards, Design Award for the Industrial Fabric Association International, Hugo Herring Award, Royal Institute of British Architects Award, Auguste Perret Prize, Fakir Khan Medal, and Balthasar Neumann Award, including many other awards. And you must have seen many of his projects. His structural projects include Deutsche Post, Mercedes-Benz Museum, UN Studios, collaboration with Warchel Leibinger, and Trump Entrance Project, and Museo del Acero with Grimshaw, and also airports in Cologne, Bonn, and also Bangkok Airport with Helmut Jahn, among others. He designs his own project also. Very well-known one is a house called R128, and I think he will be showing some of the project for us tonight. So I'd like to welcome Professor Werner Sobek tonight, and please come and speak.